Dear viewers, we present to you our proposed redesign of auditorium titled Linking the Auditorium, a redesign for better acoustics and experience. Our group members are following shown below. We have Asin, Kausapin, Chavez, Latagan, and Marin. Next slide.
The contents for this presentation are to be shown and discussed in the following order. About the Rizal Auditorium, its as-built plans, the documentation we've gathered, our proposed methods of redesign, proposed and detailed plans, and our renders and perspectives lastly. Let's begin.
Okay, so the Rizal Auditorium or the Francisco Balagtas Auditorium is one of Mapua Malayan College's Laguna's primary locations for major presentations like thesis dissertations, performances, and more. The other locations for events like this would have to be the gymnasium or the oval. But about the Rizal Auditorium, our measurements brought us to discover its sizing is about 24 meters by 16 meters. So this space is located at the top floor or the fifth floor of the Rizal building within the school premises.
The as-built plan features 12 rows of seating and a wide stage perfect for small to medium performances. There's a back room behind the stage for backstage preparations, and the auditorium has 4 entryways or exitways. Both emergency exits and main entrances alike no windows were spotted within the space except for the BFX booth at the rear of the auditorium.
More about the auditorium. It is also included some paneling at the left and right sides of the room, which is presumably to control the reverberations of the room and preventing much echo. Though this will be checked into later with our analysis, the seating contributes to some of the sound dampening or absorption in the space, along with the flooring of along the seating area, which is also fabric material. The texture or material that we've noticed about the left and right side walls looks though is concrete and layered with some panels which appear to be fabric wrapped acoustic wall panels. They are large, flat, rectangular, and modular, a common format for acoustic wall treatments. The surface has slightly texture matte appearance, which is typical of fabric covering. The back wall, however, seems to have a bare concrete plaster walls which are highly reflective and cause strong echoes or flatter echoes, especially when positioned directly behind the seating area. We'll discuss this feature more later on. Next.
Here are some of the members of the group who went on site to measure and analyze the conditions and features of the auditorium. You can see there is an abundance of pin lights and down lights above. Two standing air conditioning units at the back as well. All of the flooring besides the stage, which is made of wood, consists of fabric-like materials. The seating can accommodate 216 people, and the stage can handle more than 20 people at a time.
So, our analysis of existing acoustic and spatial design, based on our visit and upon our assessment of the space, we noticed several things. We conducted tests to determine whether the acoustics were effectively implemented while also evaluating the aesthetics and the materials used in the installation. During the testing process, we discovered that the auditorium still requires certain improvements, and we hope to propose a more vibrant, effective redesign of the auditorium to improve the interior aesthetics, enhance the atmosphere, while also achieving better sound quality and overall performance. To name a few, the direct lights onto the audience area that were shown in the documentation pictures can somewhat create a blinding effect. Though this feature can be kept because the space is also sometimes used for tests and exams, it is not exactly a feature that can provide a suitable or comfortable environment for performances, and lectures. So, for this reason, our design solution prioritizes enhancing both visual and acoustic comfort. Another is that the wall panels at the sides of the room aren't adequate enough for the entirety of the space to completely handle the overall reverberations of the room. So, including the back wall, by the way, which is made of concrete. So, if the room were to be jam packed with users, it would already be difficult for the people in the back to listen to the presentation in the front, especially if many people will be talking at the same time. Okay, next slide.
By modifying the wall panels with improved fabric wrap, absorb, absorptive materials, or fabric wrap acoustic wall panel. With this specification, we aim to reduce unwanted reflections while maintaining an aesthetic surface. This subtle intervention works alongside the existing ceiling treatment to balance clarity and comfort, ensuring that the auditorium functions effectively as both an academic and formal space. Hence, our proposition of eight versions of wall paneling to create a more elegant look yet effective acoustic measures in the room. We hope to feature some sort of shape that integrates convex and concave waves to properly disperse sound waves across the whole room. In terms of lighting, we wish to propose a more subtle effect that complements the atmosphere of the auditorium. We hope to keep a few of the existing features without too much alteration that may cause any budgetary issues. But most of what we propose is adequate to create an effective acoustic experience. Our group intends to redesign the lighting of the auditorium to balance performance with academic functionality. The current direct overhead light will illumination more evenly, but introducing a dimmable zone lighting system and space can easily adapt, providing bright, uniform lighting suitable for exam and lectures, while transitioning to warm, focused lighting that enhance stage performance and audience comfort. For the ceiling, our group chose wood, particularly perforated wood veneer panels with mineral wool backing because it provides warm and refined aesthetic while also supporting acoustics. Instead of leaving it as a flat reflective surface, we propose using perforated or slatted wood panels backed with mineral wool and an air cavity. This allows the wood to scatter sound evenly across the space while also absorbing excess mid and high frequency noise, improving both speech clarity and musical quality. By combining the natural look of wood with hidden acoustic treatment, the ceiling becomes both a design and performance solution. Next slide.
Shown here are our proposed floor plan. We did not change much and we wanted to focus more on these following treatments: installing sound-absorbing wall panels on several sides of the room, diffusers at the back wall, a ceiling design that enhances sound distribution, and keeping the existing carpet flooring.
Here are our detailed plans with some callouts for the flooring, ceiling, curtains, on stage, seating wall panels, and wall details.
More detailed plans. You can see that the curvature of the ceiling is evident. It is made up of varying waves to promote sound distribution. As discussed before, that concave and convex waves in varieties can enhance the spread of the sound waves to different areas of the room. It also gives a lovely flair about the auditorium, providing an elegant look that will definitely catch the attention of its users.
Okay, and here are our perspectives. If rendered, it should showcase the cove lighting at the sides and some dimming light features. But anywho, that is about it for our presentation, and we hope you took in all of what we said, and we also thank you for watching. Okay, bye-bye.
Sabi